So we've talked about a number of different aspects of DevOps. And, let's remember where this all started, right? The idea that the development part of your job and the operations part of your job are not 100% separable. And that, again, is something that really, with the advent of platform as a service and the ease with which we can deploy web apps on hosted infrastructure, it's led to sort of this crossover where as a developer, you cannot really be ignorant of performance and security considerations that arise during operations. As an operations person, you cannot be ignorant of the abstractions that the developers are using because those abstractions may have positive or negative implications on performance and security. So DevOps is sort of where the boundary where these two things come together. And I'm going to try to take out sort of 2 or 3 big lessons from the different aspects of performance and security that we've talked about. One pitfall is what I'll call sort of premature or unwise optimization. There's a post that you can search for from several years ago, maybe almost 10 now, by Professor Joe Hellerstein here at Berkeley. I think his was called "You Are Not Facebook." Maybe it was "You Are Not Google." But the idea was, look, yes, your website should be scalable. It should have good performance. But most people greatly overestimate their own ability to do better than a good framework and a well-engineered database can do. So until and unless you get to a scale where the existing highly tuned tools are not sufficient for you, don't worry about doing that kind of optimization. Worry about good design. Worry about a design that doesn't paint you into a corner for performance. Worry about a design that doesn't expose glaring security holes. And, hopefully that's because you are wisely using a framework and following its best practices. Now, at the same time, we saw from Google and others that speed is important and that, talking about the average response time is not useful. You need to talk about the experience that most people are having. So things like the 95th percentile. And in that regard, the best thing you can do is monitor. Monitoring will tell you where the problems actually are. We showed a brief demo of one of the monitoring frameworks, New Relic, where you can actually drill down and ask questions like, which database queries are the most expensive? Which controller actions take the longest to run? Which views take the longest to render? And in some cases, you can see from the information provided by these frameworks that there are some requests where most of the time is spent in something that you have no control over. So understanding where performance benefits can be gained and where the bottlenecks are is sort of step 0 before trying to do any kind of optimization. We also saw that when you can use horizontal scaling, that the ability to scale horizontally is sort of much more important and a much bigger benefit than the performance of each individual machine. So what does that mean? It means that in your application server and your web server tier, you can get away with using machines that are not super performant because you can always add parallelism. Now, of course, there's a lot of different ways that things can slow down, but in general, your single machine performance just has to be good enough. And of course, more important than sort of worrying about optimal performance from the beginning is make sure your design avoids terrible performance, right? If you have table joins that are just overly complicated, or if there's queries that are just so expensive that you kind of need to rethink your data schema, it doesn't matter how highly performant your hardware is, right? Highly performant hardware cannot save you from a bad design. On a related note, cloud computing is almost like magic. This lovely 3-tier architecture means that we can have sort of different numbers of computers in different tiers, but that does not automatically guarantee scalability. And in particular, we know that the database is not easy to scale. Even if you do scale your database up, you want to get the expensive operations out of the way. So again, using monitoring to understand where are the operations where there is the most benefit to be had. And remember that, being nice to the database, there's a lot of different ways you can do it. Part of it is just your schema design, but part of it is avoiding needless queries, like the N+1 query problem. Part of it is the judicious use of indices so that queries don't have to do table scans. Part of it is using caching in all different ways so that when information has not changed in the database, you avoid doing additional needless database queries. So the idea of being nice to your database really kind of pervades all the different parts of your app. And when you start hitting scalability bottlenecks, if you don't have enough web servers, if you don't have enough app servers, that's easy. Just add more and pay money. But if you run out of database capacity, that's harder. So that's really a reason to sort of have this kind of database first perspective. And again, look at the monitoring to understand, is that really where your performance bottleneck is? or is it somewhere else? So like we said, caching at many levels is one way to be nice to your database. Again, the tricky thing about caching is knowing when to expire things. This is yet another example where if you use the framework provided best practices, it relieves you of having to think of some of this. For example, we saw that if you think of an active record model instance as the unit of caching, and if that assumption is reflected in your views and how you do caching, Rails will automatically manage that expiration for you because it certainly knows, based on like the updated at column, it certainly knows when that model instance has changed, and therefore any cached copies of it are no longer valid. So again, by using the conventions provided by the framework, it saves you some work and, work in a sort of tedious, what would otherwise be a tedious and tricky task. And I think the sum benefit of all of this is if you can sort of, get the most out of the resources you have, you can stay in the platform as a service tier for a really long time. And I don't know if it's possible to communicate what a lovely life that is if you have not lived the much, much more difficult life of having to manage all this stuff yourself, of running your own web server, running your own database and trying to configure it, worrying about all of these security bugs, worrying about which security library just got patched and now you have to recompile the world. That is not a world you want to live in because you spend your time doing things that do not add value to your application and they don't add value to your customers. So I am a big fan of platform as a service where those tasks are delegated to people who are specialists, and the abstraction presented to me is be nice to the database and you can do whatever you want. And sort of the last one, this is kind of a fallacy, and I think it's a side effect of it's so easy to deploy software as a service, even for a very small customer, that it's tempting to think, well, my software is just used by a nonprofit or it's just used by some student club. No one's going to try to break into that site. There's nothing valuable to be found there. A lot of the time, actually, the hackers are not after your data. What they're looking for is either something where they can scam your users or use your platform as a vector for delivering malware or recruit your server into something like a distributed denial of service network of bots. So you always have to worry about your site being attacked. The other day, I was actually debugging a customer had reported a problem with a site that I manage. And the problem, it went away by itself after 10 or 15 minutes. But I was surprised because I have a lot of monitoring alarms set when something is wrong with the site, and none of them had gone off. And ultimately, I figured out that the problem actually was with Heroku. They had a DNS problem, and it was affecting some but not all of the Heroku-hosted apps. But in trying to track down the problem, I was looking through the application logs, the server logs. I was looking for signs of anything unusual that somehow didn't trigger any of my alarms. Among the various things I saw were like a whole bunch of random attacks on the site with URLs that made no sense, URLs with weird query strings. And sure enough, I did a careful Googling of some of those, and these were attacks originating in China from some well-known hacker group. Why are they attacking my little site, which contains no valuable information? Probably because they want to use it as a vector to deliver something else, right? So if your site is on the internet, it is attackable and it will be attacked by someone because a lot of these attackers are just indiscriminately spraying traffic at anything they can find. They're not after you specifically. And, like performance, it's hard to just sort of add security after the fact, right? You have to be thinking about some of these considerations as you're authoring the site so that you're not trying to play whack-a-mole later and fix all of the security holes after the site's being deployed. So I think the best advice that I can give is if you use the current best practices and tools like modern frameworks and you try to stay up to date, use a relatively recent version, it is likely that that will give you a better result than trying to do things on your own. So yet another reason for sticking with platform as a service. At the same time, you have to be prepared if a catastrophe happens. For example, one of the sites that I manage, every night it will create a complete encrypted backup of the entire database and send a copy of it off-site to a completely different server hosted on a completely different storage service, because I have to assume that someday something is going to happen where the database gets blown away, right? And then the best I can do in that case and say, we won't lose more than sort of a day's worth of data, like whatever the database looked like at 3 a.m. last night. At Netflix, which was one of the earliest companies to really move in a big way to cloud computing, there was a very famous talk that the CTO or VP engineering of Netflix used to give, where he talked about how all of their operations had been moved to AWS. They had basically sold all their hardware and they were using public cloud computing, But they would run disaster drills all the time. Part of their sort of company culture was they were constantly doing things where, in a sort of controlled way, they would induce a nightmare scenario because they needed to keep their team trained on how to respond to them so that if a real disaster happened, they would have a plan in place, right? So have a disaster recovery plan and exercise it once in a while so that you actually know what to do when a real emergency comes.